mechanical engineering friends, my name is Ivana, and with this video I decided to cover the topic of return of investment, simply because every optimization project requires development of benefit analysis or a benefit study to estimate the payback period of a project before making the investment decision. Therefore, many engineers are involved with this activity. And like any other investor, your top management will always want to know what the return of their investment is. Therefore, professional cost-benefit analysis is a necessity before the project implementation, simply to be able to accurately estimate the payback period of that return of investment. So, what an accurate estimation of return on investment gives management the confidence to put their money in the project and help them to decide their priority as compared to other investment decisions that might be on their list. Let's explore how to correctly estimate the return on investment.
So is it really art or science to estimate the right ROI? Let's explore. The fact is that nothing comes without a cost. And the first step in the benefit analysis development, even in cases of large savings, is to define them. They need to be listed and estimated, and they can be related to following activities. Process design, that includes project basic and detailed design. Costs related to equipment, which means installation of process equipment such as columns, vessels, pumps, compressors, heat exchangers, valves, fire heaters, reactors, pipelines, etc. Construction work, that includes the cost of construction works and their elements. Then costs of hardware and software. Hardware such as high-speed computer, wiring, etc. Also costs of different software packages and their license fees. Then we have cost of instrumentation and control system. Manpower costs, that include the cost of men working, and other costs such as annual maintenance and support, insurance fees, safety fees, desk costs, etc. However, the expectation of any optimization project is to bring benefit that will justify the cost in reasonable time. Usually, what we mean by a reasonable time is considered to be 6 to 24 months. Benefit estimation is a multidisciplinary act. It involves plant operators, production and process engineers, control engineers, maintenance engineers, planning and scheduling departments, and plant managers having an idea of company vision and future path. The best way to understand the process and its economics is to perform a process analysis study with on-site data gathering. It is usually done discussing it and meeting with all the relevant players at their site. And this includes the following steps: to meet with the operation, process engineering, and all other relevant staff at their workplace, which it can be a control room, plant conference room, etc. Then explain the project outline and objectives of the benefit estimation procedure. Encourage the team to provide all relevant inputs to understand the idea, collect their ideas. Understand the potential areas where optimization can be exploited to reduce variation in key process variables and fetch benefits. Benefit estimation procedure can be divided in a couple of milestones. When developing a benefit study, the key steps are the following. Milestone number 1. It includes initial screening for suitability of the optimization project. Milestone number 2. It includes process analysis and economics analysis, while milestone number 3 takes into account and understands the constraints. Milestone 4. The goal is to identify qualitatively potential area for improvements. Milestone number 5 goal is to collect all relevant plant and economic data, while milestone 6 needs to estimate change in key performance parameters, yield, throughput, energy consumption. And then final milestone 7 it needs to estimate the economic value of all the effects. Let's start with the milestone number 1, that is initial screening for suitability of the optimization project. In this step, it is decided whether the plant under the study is a potential candidate for an optimization project. And to screen the plans for suitability of implementing any type of process optimization project, it is necessary to know what are the key opportunities of optimization. So the primary candidates are very often high volume units, such as crude distillation unit in refinery and big petrochemical plants. Due to the large scale of operation of these units, even a small improvement in operation results in a very significant economic benefits. Conversion units, such as catalytic crackers and hydrocrackers, petrochemical plants, they are also very good candidates to apply different types of optimization. The third group of good candidates are units that produce highly valued products. Even if the unit is a low volume unit, the benefit can be quite significant for increased product recovery. Many specialty chemicals applications fall under this group. The fourth group of candidates are units with a high consumption of utilities. Many fractionation trains fall under this group. The products are over-purified so that the effects of disturbances do not cause the products to go off specification. And the fifth group of candidates for optimization are units that are subject to frequent disturbances, such as complex distillation towers in a refinery. They provide a very good example of this type of application. Based on this criteria, an initial screening may be done to know whether the plant under study qualifies for any kind of optimization project implementation. Then we go to a milestone 2, to look into process analysis and economic analysis. A full understanding of the process is very much essential to estimate the potential benefit. There is no any shortcuts here. There is no hard and fast rules on how to understand the process, but the following questions need to be answered to give an idea as to what to ask the team which will facilitate the whole process. Some of the questions that need to be answered are the following. How will the economy of the unit be improved? What are the top management goals to operate this unit? What are production targets? How are these targets met? What are the raw material and utility specific consumption targets? What variables will indicate unit performance? What are the operating objectives of the unit? Is quality control currently good or poor? What problems do panel operators face on their daily basis? Is there any control problem or controller tuning problem? And much more questions. Which takes us to milestone 3. Need to understand all the constraints. Most often, where the bottleneck is, there is also an improvement potential. And this is why it is essential to understand the constraints of the unit and use these questions as a guideline to understanding your constraints. What are the constraints that prevent the plant from maximizing its economical benefits? Are there any raw material utility limitations? Are there any capacity limitations? What are the quality specs and how does current plant quality stand against them? What are the safety limits of different process parameters? Are there any major equipment limits, like reactor, compressor, or distillation tower? How will catalyst efficiency, reaction selectivity, or yield be impacted by an increase in capacity? What are the process instrumentation limitations? Are there any valves that operate and 100% open? This takes us to milestone number 4, and this step is to identify the potential area where optimization project can bring benefit after it is implemented. And this is the area that needs experience and expertise. There are no hard and fast rules here, and they vary from plant to plant, company from company. It is the job of the project engineer to quickly detect the potentially profitable area while discussing with the plant operation and process engineering team. Note that sometimes data analysis and observing DCS parameter trends will help to pinpoint the potential areas. Sometimes doing a detailed simulation project will. The rule is to investigate the profitable areas and look for any opportunity that exists in the plant under investigation. And after that, we come to milestone number 5, where we need to collect all relevant plant and economic data. And we usually use historical data and trends for all the following parameters. We need to collect all the parameters that have an influence on plant economics, all parameters that represent any constraints, all parameters that represent the quality of the product, whether coming from an online analyzer or the offline lab analysis, and all parameters where process control is not good. After that, with milestone 6, we are able to estimate what is the potential change in key performance parameters, such as yield, throughput, and energy consumption. It is clear that different types of optimization, whether a process design changes, troubleshooting, operation improvement, loop tuning, or advanced process control, will facilitate shifting the average process value near to its limits or constraints. How this will translate to improve the process performance and how that can be quantified is the main activity of this step. The method of calculation will vary from plant to plant, and this has to be discussed with the plant process engineers and all engineers involved. Which takes us to milestone 7, where we are able to estimate the economic value of all the effects. The purpose of this step is to make an economic viability study report of the optimization project. Note that any kind of optimization project will be seen as an investment by company top management, and like any other investment, top management will want to know the return on their investment before deciding whether to implement the project or not. This is the reason it has to be very simple and clear message for the top management. The purpose of this step is to summarize all the potential profitable areas where it is expected that successfully deployed project will result in the economic benefit. All the benefits should be quantified in money terms and added in payback period or return on investment framework, because company top management wants to see the payback period and a cost-benefit analysis in a simple table. So the purpose of this report or presentation is to present a clear picture of the investment necessary and profit expected that will enable the top management to make a correct decision on optimization project implementation.
I hope this lesson was useful for you. If yes, don't forget to subscribe to my channel and also read similar stories at the website simulatelive.com. This topic is also covered with the course Process Optimization with Predictive Analytics 10-Days Challenge, and you can learn more about it by following the links in the description below. That was it. Thanks for listening and bye-bye.